So I'm Kaylee Tatum, and for my project, I chose carbon reinforcement of silk. So silk is produced by both spiders and silkworms, and it's been used in manufacturing and in the medical field for years now because the tensile strength is 5 times stronger than steel. And it's also biodegradable, which makes it a great alternative to plastic. The reason why it's being used in the medical field is because of its biocompatibility. After silk has been sterilized, it makes great thread for sutures and other things. It also has this amazing ability to be manipulated. So silk can be reinforced with a bunch of different products. In our picture here, figure D is just standard silk, whereas figure A, B, and C have been treated with different chemicals, and you can see how that completely changes the structure of silk. So by doing this, we can increase the tensile strength or the flexibility or the elasticity. And today we're going to be looking at the carbon reinforced aspect of steel. So one of the ways to reinforce silk with carbon is by dipping it into these carbon nanotubes or graphene. This increases the tensile strength of silk from 1.1 megapascals to 1.7 megapascals, which is actually a huge improvement. And even though it's dipped in these carbon nanotubes, it retains its biodegradability, which is the whole reason why we want to use it instead of plastic. The carbon also makes the silk conductive, which would make it a great thing to use for medical sensors. So another way to reinforce the silk with carbon is actually by changing the diet of the silkworms and feeding them this carbon nanotube solution, which they found can increase the tensile strength all the way up to 1.07 gigapascals. However, this solution doesn't work with the orb weaver spiders and only works with the silkworms, which is an issue because orb weaver spiders are a main source of silk production. There are some other issues with this project, such as when the silk dries after it's been dipped into the carbon nanotubes. When it dries, it shrinks and those carbon structures can break down. That's why it's actually preferred to change the diet of the silkworms and to feed them the carbon instead. And they found that by purifying that carbon nanotube solution, it can increase the carbon concentrations within the silk, and they've managed to get the tensile strength all the way up to 1.82 gigapascals, which is a huge deal. Another solution to the drying issue is to actually microwave the silk, which can create these helix structures inside of the fiber. The helix structure doesn't improve the tensile strength, but it does improve the malleability, which has major applications within the medical field, as they'll be able to use this to reinforce prosthetics or whatever new thing that there is that they're working on. And those are my sources. Thank you.